Hello everyone, my name is Sachin Abeywardana. I am a senior machine learning engineer at Canva. Fun fact about me, I don't drink coffee, but I do lots of salsa. And I don't mean the dip, I mean the dancing salsa. Thank you.
Welcome back to the MLOps Community Podcast. I am your host, Dimitri Os, and today I'm flying solo, but I was just talking to Sachin. Wow, I have so many notes from this conversation. There was so many different threads that we pulled on, and we talked about his journey, but we also talked about the trade-offs that you get as a machine learning engineer and having to think about the broader product and the fun stuff that these machine learning engineers like Sachin enjoy doing, which is that deep down hard math problem. So we get into that. First thing, I knew it was going to be a great conversation because he started it with, I did my PhD and it was a complete waste of time. Bam, that's how we set the tone for this one. I loved that. But he was very open, and I loved another thing in this conversation, which was how forthright he was with the downfalls of not understanding the broader product and bringing machine learning capabilities or AI capabilities into the product. So we went down a bit of a rabbit hole on how he has been remedying that and why he feels like it is important. And we finished it off. One thing that he mentioned, a little bit of a spoiler alert, but one of the last things he said was, it is so important for machine learning engineers to not only understand the metrics of their machine learning projects, but also to understand the metrics that the product team is looking at, because that will help guide you as you are creating your different AI, ML initiatives within the company. All right, I hope you enjoy this conversation with Sachin. And even if you don't, what would mean the world to me is if you share it with one friend and like or review or give us some stars wherever you are listening to this episode. And sometimes that's because I have too much shit open, so I'm going to close like every other app. Yeah, I'm going to, I don't need Spotify open right now as much as I love it, or Signal, or 20 Mozilla Brave and Safari. I just need Chrome right now.
Have you got ChatGPT installed?
I don't. Do you?
Not. I mean, I just paid for the premium one today, so literally today. So that's been amazing.
Step.
Yeah.
It's
I mean, if you're a programmer, you must have it. So that or Copilot.
Yeah, totally. It has become something where at least to stay up to date and to be in with the times, you have to be using it. It's one of those early adopter things, I think.
Yeah. I mean, I'll probably describe myself as a power ChatGPT user because I'm really bad at writing shell scripts, right? So I've just gotten decent at writing Python, but shell scripts is a completely new world. So what I do is go ChatGPT and say, write me a code to download S3 files. It'll do that for me. So, so the small things like that, it's really good at. And I'm sure it'll be much better things as we go along too.
Have you messed around with some of the tools that help you validate the output and make sure that it's real scripts, or are you just plugging them in and then once they work, you're good? Or
I am hoping for the test. And look, I do test it myself, right? But because these are production code that I'm writing. I mean, because I'm an ML engineer, that is the quality of the code. I am very bad at writing tests, I'll admit. But saying that, you can get ChatGPT to write the test as well. So
yeah,
it's so you can get around that. That's an easy thing to get around.
Actually, one of the hackathons that we had recently was in Berlin, and one of the submissions, I voted for it to be one of the winners, but the actual demo broke, so the other judges, wasn't me, it was the other judges. I'm going to just throw them under the bus right now. They were like, oh, it was good, but the demo didn't work. And the submission was that you have code generated, and then if there's errors in the code, you have agents that go through and they grab the errors and then they paste it back into ChatGPT, and they figure out what the error is, and then the agents go and they update the code. So
Yes.
it's the full cycle where you can be a little bit more, I don't know if confident's the right word, but just lazy, I guess.
Yeah. I mean that is valuable, because right now what I do is, if there is an error, I manually go back and paste it, and then it goes, oh, sorry, you're right, and I'll go and correct it, and then I paste it back, and then just keep going back. So if that process is automated, yeah, sure, I can see the value in there on its own.
Yeah, I think the hard part right now is just dealing with agents that are reliable. That's where I think in all of the hackathons that I've seen, they kind of fall over at a certain point. And so I know there's a lot of hard work being done by a lot of people out there to make agents more reliable. And that's active cutting edge piece of this machine learning and AI industry. But
so, I mean, I only have a very basic understanding of agents. So what I understand of agents is that they, it's prompts, if I understand correctly, but very detailed, very specific prompts, so that you basically define the boundaries of what OpenAI or whatever it is can do. I'm not sure that kind of agent is going to last for too long, because my hypothesis, again, it's an uninformed hypothesis, is
disclaimer.
Yes, yeah, that's right. Yeah, is that it's already good at understanding language. I mean, compared to 5 months ago, it's really good at. So, I mean, when I tell an agent, I know exactly what I want. I'm assuming that exactly what I want bit is only going to get better with more training, more data. So, like even right now, ChatGPT has this thumbs up and thumbs down thing. So I'm assuming that if I give a thumbs up, it will keep that as a training data, go back and feed it back in, especially if it gets it wrong, right? So, especially if it get the wrong ones are the most important bits, right? So that's what you need to feed back and improve it. So, if it's a prompt engineered agent, I can see it getting better. But if it's an agent that actually, I don't know, accesses the web or accesses a Python terminal, those things are amazing. Yeah. So because that just extends the capabilities, right? So.
Yeah, exactly. So, all right, dude, let's talk a little bit about what you're doing and what you're up to. I've got your whole history here, and I mean, you're so humble. You were like, I don't know, because all the other people that you've had on the podcast are big names and big hitters. But you're, in your own right, like, you're also quite a big hitter. What's your story? Give us the breakdown. I know you got a PhD. You went to what?
That was, let me start with that, right? So I did my PhD in Bayesian Machine Learning, and if I'm being honest, that's the biggest waste of my waste of time that I've ever had. So
no way. Why do you say that? What?
So I spent 4.5 years doing a PhD, right, in minimum wage. It was one of the loneliest times of my life. So I do not recommend doing that unless of course you're rich and you don't have anything better to do. Anyway, so the reason that I personally regret it is, like, when I was doing mine was very theoretical. I was doing in an area called Gaussian processes, and at the time, the best that we could fit was like 1,000 data points, right? And that was the best that we could do.
This was like 2010?
Between 2010 and 2015. So when neural networks are just starting to take off, right? So I kind of missed that neural network bus, I suppose, during my PhD at least. And yeah, I think we got to a point where it was 1 million points, so which was amazing for a Bayesian thing. So anyway, once I finished my PhD, I did this course on basically it was just an MNIST data set, right? So it's 60,000 data points, and it was just amazingly fast. So you just did a few layers, and like you got this near 100% accuracy, and that was like, whoa, okay, I'm not going back to Bayesian ever again. So, but look, it's okay. Bayesian sites have come back, like all the stable diffusion models that you see have some Bayesian foundation in them, right? So it is grounded in the Bayesian side. But the point is, in terms of speed, in terms of what you can do with the model, the neural network's capability is just so much bigger than what you would do from just using Bayesian tools. So after that, I got lucky enough to start at a small startup that had just been bought out. I started there as a data scientist, mostly just analyzing data. I didn't actually know any Python at that point at all. So I think I got lucky getting hired to mostly a software company. So that's where I started doing like Python, learned about Docker, started learning about deep learning. So that the next 6 months, it's in that 6 months, I feel like I learned way more than what I did in those 4 years. So that's again a reason to say, oh man, PhD really wasn't for me.
So when you say you learned a bunch more in those 6 months, it's you learned useful information for the industry as opposed to this deep dive on the research side of things?
It's to be honest, actually both, right? So the thing with doing a PhD is that you go deep into the rabbit hole that might not matter to the rest of the community in a few years, right? So that there's always that risk. But the good, like, I'm still obsessed about the math side of things. So I still try to keep that side as well as the technical side up. And the good thing that I saw was that the deep learning, like, did all these weird tricks to apply their problems to very different domains. I think like one of the early examples I can think of is like GANs, like generating images. Just the way that they did that was it's very different to how like statistical machine learning had done things, because they were just going, here's a classification problem, here's a regression problem, the standard stuff, and let's try and fit it. Whereas this thing came along and said, hey, let's try and generate images, right? So it's still using very similar tricks, very similar loss functions, but used it in a very different ways.
Yeah, and so then you realized, oh, maybe I need Docker, maybe I need Python skills, and you kept up with the math. And from there, though, like, you've done some awesome stuff. And especially what I love about your story is that you've stayed on this deep learning path, and you've really gone down, I don't know if it's down the rabbit hole, but you've stayed true to deep learning. When deep learning, a lot of times the criticism that we have from other engineers that come on here is like, for 90% of the problems, deep learning is overkill. Why not just use the stuff that's fast and lightweight?
That's so okay. Let me talk about the lightweight thing, right? So it's 2023 now, right? So to say that you can't deploy a deep learning model in production because it's too heavy, it's just simply wrong, right? So let's throw that side out, because like these days there's Docker now. You don't need a GPU as well. Like there's plenty of things that you can apply to without using just normal CPUs that and it'll be fast enough. So yes, like XGBoost is still better for tabular data. With the tabular data, obviously that's the one thing that non-deep learning models have a big edge on. So they've tried to beat it. Like I think TabNet was one of the first papers that tried to beat it, and it's still not there yet. But again, I do think it's getting closer and closer. The gap is getting smaller, right? So I do think it will overtake at some point. But that's tabular data, right? So I feel like, again, we're not thinking far enough. So again, disclaimer, my opinion. So for example, a lot of tabular data have text rows in them, right? So most of the time when you're doing analysis, you just go, well, we'll just extract a few keywords from this, or yeah, so do some simple NLP type things, and then let's treat this as a normal tabular problem where you have one column to predict. But the better way, I think, is to take those text data, use your favorite, your NLP transformer, and then use those extra features, and then do your predictions. Yeah, so you can go beyond what you used to do if you can combine deep learning into this whole problem space.
So it's basically a step in the pipeline, and allowing for being open-minded about using deep learning as one of these steps in your orchestration.
Yeah, that part, I think it depends on the problem. So again, if it's something traditional, like, I don't know, classify the risk of this customer, then or the churn models, that kind of thing. Yeah, sure. Like we know that we have a known process to do this. But I think what I would like to see happening in the industry is go beyond just the churn models, just your.
Would you consider like recommendation or lead scoring?
Let's talk about search actually rather than recommendation, because I'm not as familiar with that. So with search, the traditional way of doing it is to extract keywords or stem words, and then search a library and then recommend them. But you would obviously re-rank the results based on frequency of how many people clicked on them. So I'm trying to get our company to look at Clip for doing image search, just simply because when you type in a longer query, it makes far more sense. The context might matter, right? So, so if I say bird sitting on a tree, like the sitting part is not. I mean, it's if you, compared to bird sitting on a bench or bird under a bench. So that context really matters, right? The order of the words matters. So that gets thrown away as soon as you stem the words and you just take a frequency approach to finding it. So that's a very good way of getting vector databases in and trying to do vector search, especially now that there's so many competitors in that space. So I know Elasticsearch is offering that now.
Everybody. I was at the Databricks and AI Summit, and every database out there has some kind of story around how they are supporting vector databases. They're now like a vector database. I was at the MongoDB booth, and they were like, "Oh yeah, we do vector database too."
Yeah.
It's like, of course you do. Why wouldn't you?
Why wouldn't you? Yeah, and I think it's important, right? So I think in the next few years, like they will. I'm not sure about overtaking. Like there's certainly a reason to use the classical things as well. So the recent this clip model that I did, I searched for, the results were looking good, right? I searched for Jesus, right? Now, obviously, if you get this wrong, like religious things, it can be very offensive, right? So, and like there was one image of Jesus, but the rest of it was like, it's a bit questionable, right? So if you, so there are cases when you do get it wrong, you get it wrong spectacularly badly, right? So, so this is a perfect case of using deep learning as a step in your process, right? So you use your keyword stems to gather a larger than usual set of images, and then you can use your deep learning to re-rank it. So use both in combination. So just to get much better results.
Break down this whole clip. Blog post that you wrote and what you're doing. I mean, we should probably take a step back, say what the use case is, say what you're working on at Canva, because I think that's probably important to give a bit of context around what the goal was, what you're trying to do there.
So when it comes to multilingual search, we some poorly resourced languages, for example, we don't know how to stem a word, right? Or we might not have as big of a library of knowing, hey, this word maps to this when it comes to stemming. So the results when it's non-English, especially, can be, it's definitely worse off than the English search results, right? So one way to get around this is to use deep learning to try and match up. Here's my query. Here's the best image that's possible. So how do we do that? What we do is we take the query and we encode it into embeddings. So embeddings is just a set of numbers, and we would also do that on the images as well. So what we're going to do is, instead of matching words now, we're going to try and match up, here are the closest numbers that you can get. With the text encoding, what you can do is, there's actually a lot of multilingual models right now. So if you go to Hugging Face, search for multilingual, there's so many out there. And the good thing that they can do is they can map. So if I say cat sitting on a bench, and it will map to the same or very similar version of that in French as well. So the numbers will match up very similarly. And the image embedding, it's exactly the same. Really, that doesn't matter because it's just an image. There's nothing multilingual about the image. So what you need to do is I need to search in whatever language that you want to. It'll map to the same number set. You use a vector database to go and search for that in your library, and voila, you got your image.
And then, so what you were doing at Canva is you were saying, hey, how can we bring clip into this, right?
Yeah. So the clip, so the clip model is really, clip is two models, right? So clip is, how can I use the text model to project it into a certain set of numbers? And how can I take image model and again project it in a set of numbers, right? So clip is all about trying to line up those numbers so that they match. So if you think about one dimension, like you can understand that 2 is close to 1, right? So now the thing is, these are multi-dimensional numbers. So imagine that we are on this huge planet, but the distance to the center is 1 kilometer, right? And there's people randomly spread out across that planet. And what we're going to do is we have a second planet, and that's representing images, right? So now what's really important is the direction from the center to this person on the text planet, and the same direction from the center to in the image planet. So we have this little magnet that comes and says, oh, okay, this a cat image is pointing towards, I don't know, Australia, right? So and then you go and look on the text planet. Hey, which one of you is a cat? And I'm going to try and drag you towards Australia, right? But at the same time, it even while that magnet is doing that, it kind of has this pushing away effect of everything else, right? So it's not as strong with the non-cat people, but it does have a small effect of pushing away. So the point I'm trying to make is it's trying to line up the direction of the cat image and the cat text has to roughly point in the same direction. And I hope that explained that decently well enough, because now take that 3D planet and burst that into like 100 dimensions or plus, right? So that's effectively what clip is.
I just want to know more about these cat people. Tell me about them.
Yeah. Well, that's a lot of cat images, right? So that's somewhat of a problem, because obviously we will do really well when we're trying to cat images, but when we try to find non-cat images, so I don't know what's a random word, a phablet,
bouncy ball,
right? The bouncy ball. So those are very rare search terms, are very rare. It's never hardly a caption, right? Not a bouncy ball, maybe a phablet, because it hasn't appeared in a long time.
Yeah.
So there's very few of those training examples, so we don't get to see them now. What I try to do in my blog is to go, that's true that we haven't seen a phablet in a long time, but what if we take a pre-trained image, a pre-trained text encoder, right? So if I take that, freeze that model, and if I just say, okay, I'll take the last output of that model and I project it. So projection just means putting a linear layer on top, or a few linear layers on top. What if I can take a frozen text embedding, project it to certain dimensions, and I do the same on the image side, right? So again, freeze the original image model. And the reason that I try to do that is to say, let the projection try to move those people around to the right place, because the text model already understands language, right? Yeah. So that way it won't be a problem that I specifically haven't seen Phablet, because that projection should just guide it along.
So let me see if I understand that correctly. Because of the understanding in text, it's like it leans on that. It's almost like a support mechanism.
Yes.
And so it can give the direction.
Well, it gives a starting. Okay, so it gives a starting point, right? So think of this projection layer that I keep thinking of. Think of that as a map, right? So, but this map is more of a. It tells you the directions, right? So it tells you the directions, but it does not care about your starting point, right? It doesn't care where you start off from. It will always say left, right, until you get to that point, right? So yeah, so that's really the main advantage of getting that.
So I guess what's the obvious conclusion for me, what I have been beaten senseless over the last 3 years when it comes to using machine learning from the community, is what were the results of this? How did you make a business case? Like, how did you show that this was actually worth doing and worth pursuing?
So the business case in this case is more for non-English search terms, right? So I want to try and see if we can improve the non-English one. So I should say that we haven't tested this in production, so we don't know the results yet, right? So it's more of a question of can we do that for non-English ones, so that someone searching in, say, Sri Lanka, which is where I'm from, will have the same experience as someone searching in Australia, in an English-speaking country. So that's the business case. We didn't use the original clip image, which is also again on Hugging Face. Hugging Face has everything, right? So you can download whatever you want to from Hugging Face. So the reason we didn't use it was because it's relatively bulky. So my personal goal was to try and see if I can build a smaller version of Clip, smaller and multilingual version of Clip.
Canva is a very visual company, right? And so I think about all of the different use cases that you are facing at Canva, and when you think about what you can spend your time on and how you can tackle these different problems, how do you look at what different things you can bring machine learning to?
So that's actually changed a lot in the past 6 months, right? So with this,
Nice.
just because of the explosion of AI models, like we've really changed focus and tried to, we're trying to use as many models as we can, as everywhere that we can. Obviously, that doesn't always work well. You should, there's certain things where you shouldn't shove machine learning into. I mean, what you got is perfectly fine. I can think of one example where I think I got it wrong, right? So we have a creators program, and we pay according to I think how much time they spend on a certain template, or the market that they're in, depending on demand and so on, based on clicks basically. But we do have another, to make things a bit fairer, if you think, hey, the presentation, even though the number of clicks might be low, they would have spent 3 hours on that, so let's pay them a little bit more compared to an Instagram post, which is just one page. So now the point where I got it wrong was I suggested, as if we treat this as a money-making problem, we got the data on the clicks, we got data on whether that led to people paying for Canva Pro or not. So we can use that data and machine learning to say, let's divide the money up according to what the benefit was to Canva compared to fairness, so to speak, right? Or what drives up more revenue. So you can treat that as a machine learning problem, but it's also unethical in some ways, right? So you're you're forcing, well, it's unethical, and it will make Canva worse off. That's probably a better point. It'll make Canva worse off because that means people can gamify it and they can focus on Instagram posts, which are one page, gets them more money. So, so that would have been a bad use case of machine learning.
Yeah, basically because it incentivizes the wrong activities.
Correct. Yeah, that's right. So it incentivizes. Yeah. So like you could probably get a VPN and go to the bigger markets and so on. So it gives you a way of producing low quality templates as well, more frequently, because again, I'm assuming frequency will matter. So I feel like YouTube is probably one of the places where they kind of got that balance right? So in terms of with the creators, they, like when I look at my recommendations, it's always very relevant, high quality. So they got their payment system right, in my opinion. So, and I'm not sure if they use machine learning in their entire pipeline or if it's just certain bits of that.
So basically, from the last 6 months till now, you've been trying to add AI and machine learning into everything that you can.
Not okay. So Canva is there's a huge machine learning team, right? So I'm probably I'm certainly not one of the most. Yeah, there's plenty of way more successful engineers at Canva. So I think that's one thing. One thing I've struggled in the past is probably not understanding enough of product, right? So I've always gone behind these mathematical problems like CLIP, like I just mentioned. I've been obsessed with what was the reinforcement learning problem where you have bandits, right? So the payment system, I was thinking of bandits at that point. So yeah, I spent way too much time thinking about maths and not enough about product. So that's a weakness of mine.
All right, real quick one. The folks over at Prem AI have been kind enough to sponsor this episode, and they wanted to let you know that they just got done compiling the most comprehensive ebook on the internet about the state of open source AI. If you were wondering what the hell is going on in this space, you've got it covered with this ebook. It goes over everything from evaluation data sets and leaderboards, fine-tuning, vector databases, developer tooling, platforms, hardware, and of course a deep dive into the models, all of which are open source. And so how did they do this? Well, the Prem AI team has been working exclusively with the open source stack and open source models for the past year, and they compiled all their learnings and what trade-offs you need to be thinking about if you are adding some of this open source material into your stack. And that can be found at book.premai.io. You can go ahead, read it for free. It's out there, and it's also a living document. So if you feel like something is missing, you can submit a PR and get it added to the ebook by going to book.premai.io. And we're back to the pod.
Yeah, so I think I'm trying to get my head around where should I put machine learning, like you said, and I don't have a good answer to that yet, right? So maybe ask me in 1 year's time, I'll probably have a better answer.
Nice. Well, but dude, that's something that has become so apparent to me over the last 6 months because of this now ability to jam AI into so many things that were much harder to incorporate AI into before. Now you have a lot of people that are able to just get up and running, and these people are coming at it from different backgrounds. And
Yes.
I see some incredible product talent that basically unlocked a new level to their ability of designing product. And so the flip side of that is now thinking as a machine learning engineer or someone who is very deep in the AI and into AI and its inner workings, how do I also make sure that I level up and understand the product as opposed to staying very, very deep on the maths or the the other pieces of whether it's just orchestrating the data or et cetera, and not thinking about that product. So are you doing anything specific to try and get you there?
Unfortunately not enough, but I think what I'm trying to do is really talk to more on the product side, right? The engage a bit more with the product managers. I think that's really that's really key. I am noticing a pattern of the product goals still remaining the same, and you're trying to shove in AI into that product, which I think is a bad way of going about it. But I would hope.
And what do you mean? What do you mean by the product goals staying the same?
So a channel model, it's done and tested. Like we know how to do it. But the good thing and the bad thing that OpenAI has done is that it's really let people imagine, right? So there's a lot more that we. Actually, I'll have a little take on that as well. But it's made non-machine learning people think, hey, maybe we can do this and just shove machine learning. So if there was a certain black box that we couldn't do in the past, it'd go, oh yeah, let's just use AI to solve this problem.
I fully understand what you're saying there when it comes to hard problems that aren't easily solved, and thinking that AI is your escape hatch to be able to just, okay, well, we haven't been able to solve this with other methods, so we might as well try AI and throwing that in and seeing if that works. But a lot of times, I fully agree with you, is it needed? Is it useful?
I think one thing that AI is going to help you do is to really sidestep all these intermediate goals and then treat whatever the customer needs straight away, right? So I think that's really a capability that we're going to be having. So, for example, like, okay, let's talk about search, right? When people come to Canva, yes, you search for images. Yes, you will search for certain fonts, but end of the day, that's not really the goal. That's like a minor step to get to that goal, right? So what AI is going to given us is the capability to go, okay, what they're coming to do is a birthday card for grandma. Just give them that right straight away. And so all these intermediate steps become unnecessary. So, I mean, look, we see like I am, these are extreme goals. These like you still need to safeguard your main product, right? So I'm not encouraging anyone to just go and do this straight away, right? Just be mindful of what can go wrong, because things again can go wrong really bad. But the point is, like, you can jump. There's a lot of cases where you can jump straight to the final product, final need, rather than, hey, let's tiny steps, baby steps along the way.
Yes, I understand what you're saying. There is that again, it goes back to rethinking the product. If you know that these capabilities are possible, how can we eliminate unnecessary steps?
Yeah, that's right. Yeah, or just it could be a completely new product altogether, right? So, but yes, yeah. So if you can go, here's what we have. Here's what my customer's asking for. How do we go from A to B rather than A to Z, rather than going B, C, D, right? So,
so then talk to me how you're interacting with your product team now that you have this desire to level up on the product side of things, and B, understanding of the new capabilities.
My personal goal has been to have more meetings with product managers, right? So for me, my goal is just be to talk to my immediate group, talk a bit more about what are our goals. I'm still not there in the sense that I'm still not a good enough product engineer, so to speak, right? So I'm trying to change that. I'm trying to stop reading papers and try to focus on this. But
you love that math.
I do.
It's like a drug.
It is a passion, but let's go back to something that you mentioned before about things have changed in the past few months. My personal feeling is that when it comes to machine learning, like it really nothing has fundamentally changed, right? So what's changed is that OpenAI came with this amazing product and it ignited a lot of people's imagination, which is a good thing. But I think a good way of putting this is say, if you can pose your problem as a text problem, then you are going to get far, right? But if you can't pose the problem as a text problem, so for example, risk modeling, that's still going to do your traditional ML models. That you can't use an NLP model to do the same problem. So that's when the maths becomes important, right? So when you try to do those other problems, which is not next word prediction. So yeah, so there will always be a place for the maths, right? It's just a matter of convincing product to go and explore those other things. So like I don't expect that to happen in the next 6 months. This is just such a huge opportunity to waste. Like I think we will be in this NLP hype for the next 5 years. Yeah, those other problems will continue to exist in different formats. So I think the two camps right now in the machine learning space is like tree-based models and deep learning models, right? The thing is, again, coming back to the maths, the loss function is still the same, right? They're trying to solve the same metric that they're trying to optimize over. So when it comes to marrying up maths and programming, deep learning I personally think is doing a much better job because you can do a lot of wonderful things with these loss functions and come to a conclusion. Whereas with XGBoost, I just found it a bit more awkward to define those loss functions. So will they come together? Okay. I hope so. But I don't have a informed opinion about whether they can. But I do think that deep learning will overtake it at some point. Now, Boyan will have something to say about that, as he always does. But yeah, so I do think there will be an inflection point where it will generally overtake, and I do think that'll happen in the next. If I had to bet, I would bet in the next 2 years.
Yeah, and Boyan, for people who are listening and not super familiar with it, he's a loud Twitter voice. Yeah.
But like he's a genius, right? Like I very much. He's a Kaggle grandmaster as far as I know. So it's he, if anything, has he's got things to back him up, right? Like,
yeah, 100%. So then the other question that I was thinking about, just you having your head in papers and thinking about where things are going, I've heard a lot of criticism, and you kind of hinted at this earlier, on the current architecture and it having its limitations.
Sure.
Do you feel like we're going to go past transformers? Have you seen anything that's interesting? Is that even a thought? Is that on your radar?
Beyond transformers, it's doing okay, right? So like I've seen, so the problem with transformers, for people who don't know, is the length of the text, right? So the computational complexity is O(n) squared, meaning that like the complexity of a sentence that's 4 words is like it's 4 squared compared to a single word, which is just 1 squared. Anyway, point is it's just squared, right? Complexity.
Yeah, you don't have to do public math. We can let listeners figure that one out on their own.
Yeah.
Grab your calculator.
Yeah.
We're like ChatGPT in that regard. We don't like to do public math.
We don't do public math, yeah. So that's the biggest limitation of transformers. But they do have workarounds. Like some papers are coming out. I think flash attention is probably the latest thing to try and deal with that. But point is, like I've seen a paper with 1 million tokens that it could deal with. So yeah, there's people are tackling the problem, right? So it's a version of transformers underneath all of that. So will that go away? can't see anything major coming up anytime soon. But again, that might just be me with my limited vision, I guess. So point is, it's doing quite well on its own, right? So do we need a new architecture? I don't think so, not yet at least. What does excite me though is this GraphML side. So that is far more exciting because the thing with text or tabular is that you can only look at data that's linked to it, right? So within a row, it's always the same row. Within text, it's just similar. It's a line of text, right? But GraphML, it can pull in images, it can pull in text, it can pull in tabular data. So that is, I think, going to, my personal gut feeling is that will prove far more interesting than just transformers on its own, what it can do. Just marrying up all this data. We're still not using all possible data.
So if I'm understanding that correctly, the idea is transformers we haven't sufficiently explored and we haven't pushed the limit to where we feel like we're bored of them yet. So we've got a lot of surface area to cover. But at the same time, we can incorporate things like GraphML into what we're doing right now with transformers.
Would I go that far? Like, I'd like to see that happen. The problem with GraphML are the libraries, right? They're not mature enough yet. The guy who was at Pinterest for a while, I forget his name. I think he had one of the leading libraries, but the point is, like, not many people are working on it. So everyone's excited about transformers. So there's a lot of like brain power going into that area right now. Not so much this other area, and that, fair enough. It's not a lot of value on its own, right? But I do think, when it comes to, I don't know, let's even think about SQL databases, right? So you can link up a whole bunch of data types and even missing data types, which current ML struggles with. So if we can figure out a way to link data together, I think that is where GraphML can come in and play together. I think transformers will still be a part of that, right? So there's nothing special about transformers. It's just this attention mechanism that it has. So if I'm looking at a word cat, like, how do I know which word it's paying attention to? That's really what's special about transformers. Everything else is just linear layers.
Can you explain to me exactly what graph is? Because I only know it through, I'm pretty sure I've just seen it in reference to databases, maybe, and then also like different teams on different database companies that I know are working on GraphML.
So I think we need to make the distinction between GraphML and GraphQL, right? So I think a lot of people, when they say we're doing data science with graphs, they usually mean this GraphQL thing, which is somewhat mature product. But GraphML is doing inference on graphs. So for example, I think Twitter did this. So one way of saying whether an article is fake data is to literally train a classifier on natural language, right? Now, you can get plenty of data on natural language, have people label things as going fake or not fake. But what they did differently, which I thought was really unique, was instead of looking at the individual tweet, what they looked at was the network of how these things spread, right? So fake news, what happens, the tendency was that these bots would come and retweet them, right? And it would grow at a faster pace compared to normal news. So that looking at the network, looking at how it spread, that and doing that classification on the network actually led to far more reliable results of saying what was fake, what was not, rather than saying, let's look at the content of the tweet. Because again, like, what's fake news to one person might not be fake news to others.
Or it may be fake in 2020 and then in 2023 it's not fake. And so you learn new information or whatnot. So it's really about, and graph is just figuring out how does graph play into that?
So
what was graph about that?
Right. So the graph about that was, so if you think of the the original tweeter as a node, you would think of the edges as who would read it or who would read it, and the other side of the node is who would retweet it, right? So in that case, they were looking at this like a third piece of information, which was a pace of transmission on the thing. But yeah, so that's where you get the edges and the nodes, and how do I marry up these all this data? So
you mentioned GraphQL, but then there's also GraphML. Is GraphML, does it have anything to do with databases, or was that whenever I heard graph?
Look, it can, as long as you define what the nodes are, right? So if you think of a database as a node, right, a table. Now I know I'm not doing justice to the GraphML community, but this is again in my very limited knowledge.
They're gonna riot. You're gonna see some fake news on Twitter.
Right? So, yeah. So when I do SQL queries, I'm usually joining up to libraries, right, to points of data. So sometimes that data might be missing, right? So you might get the first few columns populated and the next few columns missing. So the good thing about GraphML is that it can have a varying number of nodes around it, right? So when we're doing this machine learning over graphs, if there's missing data, it's equivalent to not having a node at all that is joining to, right? So it can have variable amounts of data points. So this information that comes into that node when you're doing the machine learning over this graph, this entire graph, depends on what it's connected to and what's already populated. So we might not have this missing data problem at all when it comes to GraphML. So I know XGBoost and stuff is quite good at dealing with missing data, but I'm very much talking about, okay, what if we treat this as a bunch of nodes coming in together?
Awesome. GraphML is the future. You heard it here first.
It's the untapped treasure. That's what I'm saying.
Oh, I like it.
Yeah.
We can make sure it's and I'll send one over to you. And that is
well, I'll send you the link of the person I talked to. Like he's I think he did a Stanford series on GraphML. I was quite fond of the way how he did it. So
nice. Yeah, we can add that to the show notes.
Yeah.
So anybody listening can also have a gander at it. And now there is one thing I want to talk to you about also, which I find fascinating when it comes to how long you've been playing around with GPT.
Yeah.
Because you mentioned that you fine-tuned GPT-2. So what was that experience? How did you go about that? And tell me more. I think there's probably a handful of people that were playing around with GPT before the boom.
Yeah. So I think what a lot of people don't realize is that GPT is quite old, right? So it's about the original GPT is about 4 or 5 years old, and people have been playing around with that for a long time. So 2 years ago, I was working this user voice team. We get all these problems from users saying, hey, can you help me with the payment? Can you help me with my design? Can we have an automatic agent having automatic replies, or at least to a portion of our users, right? So, and what I was going to do was train, here's the input of, here are the tickets that came in, here's the output, how our agents, our human agents, responded to those tickets. So you have your input, output, and I want to train a GPT model. Now it didn't, at the point, my knowledge in training those models wasn't too great, so I didn't really get too far, but so these days it's a lot easier. There's a lot of tools, you can quantize it, you can reduce right now floating point is 4 bytes. They reduced it 4 bits recently as well. So the point is there's a lot more tools. I didn't actually use any of those tools. I just did the normal fine tuning in my little blog post where I did some grammar correction thing. But point is you can do that already using Hugging Face, just using manual without having to resort to using OpenAI. So OpenAI is an easy, quick way of doing things now. It's such a it's such a knowledgeable model that like I don't need to train a very specific model for grammar correction. It can correct the grammar for you, right? Because it knows about the entire world, so to speak. So you can get around that without any training with OpenAI. But if you want to save a bit of money, if you want to do things in-house, I think it's still valuable to have those skills within your company.
That's the huge trade-off that I'm seeing, because people are able to get a quick feature out there, and it goes back to that product discussion that we were talking about before, and see if there's any value. And then if there is value, they can bring it in-house and they can figure out phase 2 of it.
I think that's an amazing strategy, right? So test it out with just using OpenAI, because at the end of the day, yes, it is like if you already set up the tools, yeah, it is cheaper to train it in-house, but you're not factoring in your engineering time, right? So you're not factoring maintenance costs and all that. So yeah, by all means, test out your product using the OpenAI API, and then come back to training a model.
Yeah, I mean, if you can, right? Because I know there's a lot of use cases out there that are not allowed to send data or do anything outside of their little walled garden. So in those cases, it makes a lot of sense. How have you found, I guess you probably are very opinionated about the control that you have with models that you are working on in-house as opposed to sending out to some third-party API. Have you looked at those trade-offs? I am guessing just from talking to you for the last hour that your opinions are that it's better to be in-house always, although you're not.
No, I'm not that strictly on that, because end of the day, there's only at Canva we have, I think now we have about 50 or 60 MLEs, but we have a lot more teams, right? So if you don't have an in-house ML engineer, obviously you can't borrow other teams' engineers. So yeah, by all means, go ahead and do this, because so a lot of problems that ML engineers can do have been, especially if you're in the NLP side, which is what I was, can be done by OpenAI, right? So it's a back-end problem now. So it's no longer an ML problem. So it's a very much a resource problem, right? So do you have MLEs? Two, do the MLEs have different problem to work on, which is far more important, right? So, and the third one, I guess, like the very important thing that you mentioned is speed to market, right? So which is really going to be crucial for a lot of companies in the next few months.
There's a piece that I wanted to go down the rabbit hole a little bit of leading other ML engineers and leading teams, and how you look at that, and what have you found to be successful, and where do you feel like maybe others can make missteps?
Yeah. I think I've made a lot of mistakes, right? So I think the biggest mistake that I've done in the past is really not aligning or understanding product, right? So I would too often be interested in a mathematical problem, whereas the problem really that brings in the money is very different to that. So that's been a huge weakness of mine, and I think I think maybe I'm brushing everyone with a broad stroke, but I think that is going to be a problem of MLEs, especially if you come from academic background, right? Trying to make that transition from academia into industry where the motivations are very different. I think people, if I was to advise my younger self, what I would tell is engage with product a little bit more often, and faster, simpler models, and that would well, maybe not simpler models. I still do think that like all these cool new toys do make a difference, right? So let's chuck away the simple models for a second. But fast, like speed is crucial, right? Speed of how fast you finish your model and move on to the next is very, very important. Yeah, just so you can show off a few more toys. Right? I think that's the best way of putting it.
Yes. And talking about that, the 1% of these complicated models and these hard math problems, how do you go about looking at the trade-offs of that? Because it seems to be a theme of, hey, there are very valuable problems that you can hit.
Yeah.
You just have to choose your battles.
Yes, you had to choose the battles. Yeah, I think that's a very nice way of putting it. If I was to put a concrete number, I would say try and get a turnaround time of your models of 3 months. I think that should be the absolute max. If whatever you're doing is taking or you can see that it's heading down that direction, maybe it's time to look at a different solution, work on something else. Because at the end of the day, what the business really needs is you to deliver, right? So coming back to Hugging Face, the good thing about Hugging Face is that, and all these other fancy libraries, is that they've given you a lot of tools to do that, right? So you don't need to compromise on the fancy stuff if you can use these tools. So that has changed, right? So by all means, go for bigger, more complicated models, but use the tools that are available rather than trying to do everything from scratch. So again, this is me speaking to myself, but I think that a lot of people will resonate with that.
I also think so, and it is one of those reoccurring themes that comes up time and time again on this podcast, and I don't think we can say it enough. What are some signs in your eyes that things aren't going as they should, and maybe you need to scrap it? And how do you have that kind of self-talk of hold on just a little bit longer, or let's scrap it?
I found one thing I found surprising about myself is I get too attached to projects, right? I'm surprised that I do that, because I know that I want to move on to different things, but I don't really have an answer for that. But let me talk about something that's tangential related. So one thing I didn't understand was about metrics, right? So when I'm talking about metrics, I'm not talking about your precision recall scores. I'm not talking about accuracy. What I mean is like product metrics, right? Which can be very different to what machine learning engineers think. So my keyword model, for example. So in that case, one thing that the accuracy the metric that product cared about was about the pick rate, like out of the keywords that suggest how many of them actually picked. So I think that's recall in ML terms. Now, like in weights and biases, I did my precision recall. It's very different to what the final recall was, right? So it's in English it's close. In non-English it wasn't close, right? So so I think I should have paid a lot more attention to testing my model as fast as I could, and then coming back and iterating, right? So now I've moved on to different projects, so I can't quite improve that model at this moment, which is a shame. But point is, I should have been faster. I should have been using the Hugging Face libraries rather than do my own thing. That's focus on metrics, focus on product metrics. I think that's a good way of figuring out is your model going the right way it should be.
That's so good. That is, it just hits home that idea of product and how important it is to have that product mentality and recognizing what's important in it. It's it's like human nature, having a hard time letting go of your creations, and then B, it's like, at least inside myself, I also find myself not wanting to reach for off the shelf solutions, and trying to think, oh, I could do this better. And so almost reinventing the wheel.
There is value in being able to tinker through things, changing things. And I do genuinely think that it will make you a better engineer in the long term, but the business also needs you to be a different person in the short term, right? So it's a question of balancing that, and balancing things is probably the biggest thing that I struggle with today. Like, yes, you got your product versus reading papers problem as well, but I'm a parent now, so I got 2 kids. I cannot keep up with the explosions of papers that are coming up. So yeah, so that's a bit of a real struggle that I don't have an answer for.
I feel you, man. I also have 2 now, and just trying to keep up with everything is a job in itself.
Yeah, like, and my children are very demanding of my time. They're getting older. The more time that they demand of me. So yeah, it's a bit hard to do right by everyone. So, but again, I think if you can get your product thinking right, you can kind of get away from not needing to keep up to date with absolutely everything. Just understanding what's important. I don't know what's important, because these days the only one thing that seems to be important is just the OpenAI API, and everything else is just blah, whatever. I would love to see how other parents, ML engineering parents, deal with machine learning these days, because that's something, a perspective that I'd love to hear about, because this is a very, very demanding job, being an ML engineer. So.
Excellent. Well, Sachin, this has been a brilliant conversation, man. I appreciate you doing this. I know it's late where you are in the world. I'm going to let you go. We'll end it here. Thank you so much, man.
Thanks for having me. Really appreciate it.
I'm Emmanuel Mason, machine learning engineer at Stripe and author of Building Machine Learning Powered Applications. And if you don't want your machine learning models to explode, well, you should subscribe to this podcast.